Good morning, everybody, and welcome to the re-recorded version of the session that we originally did at the Dare to Be Great. Unfortunately, had some issues with our audio, so this is a newer and cleaned up version for you that hopefully you can enjoy. So I'll just start off with an introduction. My name is Matt Kopapich, and I'm the Chief Technology Officer at Evans. So today in this session, we wanted to talk about control rooms in general, because they are a critical element of the overall emergency management and response system. And, we want to look at what these spaces look like and what you should consider when approaching designing them in normal and upset scenarios, but also provide a little bit of a perspective of what other industries are doing and how can we leverage lessons learned. A lot of the sessions that we talk about and we listen to is about lessons learned. And so we can discuss some of the examples of how control room design can reduce operational risk and improve performance in these upset scenarios, as well as some of the things to consider in the design process. So when we talk about lessons learned and what drives us, really there's unfortunately several examples that have tested how control rooms function. A lot of you are familiar with the Denise Amberley story, and a lot of you have listened to Matt talk about the Mandalay Bay shooting. An interesting perspective of that is what was going on within the comm center during these events. And these are the types of things we want to look at and analyze so that we can take lessons learned and improve these operations moving forward and in the future. When we think about the dispatch operation, if you think about it like a pyramid, any comm center starts with obviously a building. There's power systems, there's communication infrastructure, all of these different things that need to be put in place. On top of that, there's things like IT systems, operational support, building management systems, so all these different elements that make the operation work. And then as you kind of zoom into the comm center, we consider things like radio systems, CAD systems, other software. But all of this infrastructure and all of these base systems are all geared around you, the dispatcher. This is what it's built for. And so the idea is that, dispatchers are the reason the comm centers are built. However, more often than not, the specific needs of the dispatcher are not considered until late in the design process. And what that forces is certain compromises, and oftentimes it leads to environments that are designed based on technology or budgets or other circumstances. But in an ideal scenario, this pyramid should be designed around the needs of its main customer, which is the dispatcher. I'm going to take a step back and just very quickly talk a little bit about Evans to give you an idea of who we are. So Evans' mission is to design and equip mission-critical operations. And what we mean by that is everything within that environment, within a comm center environment. So our expertise, as you'll see, is within the four walls of what we call a control room suite or a comm center suite. One of the specific things about Evans is we do about 20 to 25 control room projects every month. And that really gives us a finger on the pulse in terms of where these environments are going and what are some of the ongoing changes or lessons learned that happen across these environments. We've been around for a very long time. We support around 12,000 installations around the world. And we have the unique ability to provide a single operator position or do a complete control room fit out in terms of not just operator workstations, but architectural elements, lighting, acoustics, etc. And what's specific for us is every project is uniquely designed and built to customer specifications and or requirements. In terms of the scope of services for Evans, we have we essentially look at the control room or a comm center as a life cycle. So we have the ability to support a comm center through the entire life cycle, starting with consulting, which deals with conceptual design, which looks at ergonomics, human factors, technology, all of these different operational models. Then we have a group that looks at control room design, which is more geared towards the architectural approach, doing architectural drawings and design, structural design. And then we have a construction team, which does the full construction of control rooms. And obviously what we're known for is console design and manufacturing. And then we also have Evans Care, which is our ongoing preventative maintenance and service and console cleaning business. So it's our ability to kind of be exposed to and look at the entire life cycle of a comm center operation. We also service several different what we call market segments. The one thing that's unique across all of them is they all have 24/7 operations, and this allows us to cross-pollinate and take lessons learned and leverage some of the experiences we have in other markets so that we can bring thought leadership and kind of the latest and greatest in terms of operations to our customers. So when you think about approaching planning an ideal control room, it really you have to think about considering all the different aspects that might impact the operation of that center. And early consideration really is key. So if you were to try to break it down, there's kind of 5 general areas to think about when kind of approaching the design of a comm center. So the first one is physical considerations, and that's kind of where you think about things like architecture. You know, your existing space. Is it a new building? Is it brownfield? So are you doing a renovation? Looking at your mechanical infrastructure, so your HVAC systems, filtration systems, looking at any regulatory requirements you might have in local jurisdictions, any infrastructure requirements such as power, data distribution, even fiber optic infrastructure. So those kinds of things. The other important element to consider is technology. So there's core technology infrastructure, which are things like your communication systems, your CAD systems, radio, phone. But then there's also user-focused technology, and this is technology that allows the operator to be more efficient and allows them to have greater situational awareness. Also considering things like collaborative technology, so the ability to share content within the comm center, but also with other agencies and be able to kind of collaborate across different functions. And of course, considering cybersecurity. But probably one of the most important elements to spend time on early on in the process is operational requirements. And this is really kind of defining what your mission is, what exactly you want to get out of your operations. So, your operating model, look at your comm center in normal versus upset operations, which is extremely important, and look at any regulatory requirements that you might have. In terms of flexibility and scalability, the thing that most often dates any comm center is the evolution of technology. So what you want to try to build in is flexibility and scalability, both in terms of technology, but also in terms of your operational scope, so that you can kind of move resources around and be able to have agility as your mission evolves. And of course, in the middle of all of it is the people, and that's really, as we said earlier, what the comm center is supposed to be designed about. This is where we want to look at things like ergonomics, HMI considerations, so human machine interface, look at character sizes, how is the information displayed, certainly have a great emphasis on operator comfort, and then employee retention. One of the big challenges is retaining employees and providing that sense of ownership and pride. And I think it's a very good objective to strive for, because the better your comm center is from an environmental standpoint, the happier the dispatchers will be, and the better overall environment and satisfaction they will experience. So when we think about who is the control room designed for, I like to put up this picture of kind of a Ford Explorer, SUV. Why is an average cost of a police cruiser $75,000? Well, the reason is that everything is specifically designed to their operation, from gun holders to being able to secure the laptop, to have the piece of plexi or bars to prevent a suspect from jumping into the front seat. All of those things that are critical for the officer to be able to have that function properly, as opposed to the right hand image where you can go to a dealer lot and just buy a regular Explorer, but your laptop's going to fly all over the front seat, your guns are going to be scattered all over the vehicle, etc. So the idea is that it's purpose built for a specific mission, and control rooms should be looked at exactly the same way. When you're making compromises and taking shortcuts, it can eventually lead to fundamental errors in creating that ideal environment. And there's a perception that this is a cost issue, but actually it's not. What we find is it's typically a process and safety issue. And the earlier you make this consideration, the less of an impact it's going to have on the budget. So when you look at a control room in general, really you have an operator interacting with technology. And in most cases, there's multiple operators interacting with the same technology. Then there's also the human interactions between the operators and communication. And then you also have additional layers. You have supervisors and managers, you have IT support. You're going to have a 911 call coming into the center, and then you're going to be dispatching it to other individuals such as fire, police, EMS, depending on the function. So all of these have different links of communication within that environment. And this is why, any comm center is a complex and unique process for each environment. No two are the same. Some of the considerations to look at when designing these centers is things like ergonomics, looking at your IT infrastructure, architectural facilities, your electrical network, your operational model. All of these different factors need to be taken into account to be able to create that ideal environment. So I want to talk a little bit about ergonomics. Ergonomics is not an exact science. It's very much influenced by operational conditions and needs. And really, what it should focus on is providing you the ability to kind of have maximum comfort. So if you look at the upper left-hand image, obviously a textbook example will show you how you should be sitting at your position all day. And obviously, none of us really do that. In fact, we want to create environments where you can change postures and be able to kind of move around while still being able to focus on your task. I like to show the image on the bottom right hand side. This is an air traffic control tower in Omaha. And you can see the two operators. The one on the left hand side is landing a flight. So you can see that he is very, very much focused on the task. You can see that the muscles are kind of tensed and he's hunched over. And then you see the gentleman to the right who doesn't have an active flight coming in, kind of sitting back with his foot up. That's the whole idea. We want to create that environment where you can safely change posture and be able to kind of, fluctuate between tasks and be able to relax your body. The other thing to consider on ergonomics is most people think about physical ergonomics, but in fact, ergonomics as a science is broken into three major components. The first one is physical, and that's things like, sight lines, reach zones, sit to stand features. But the other important considerations are cognitive ergonomics, which is really the ability of the human brain to process information. And then there's organizational ergonomics, which is really looking at the structure of communication and interaction. In a comm center environment, all three of these are extremely important and should be considered in the design. So obviously, physical ergonomics in an ideal case would start with looking at all of the different equipment that an operator needs to interact with and placing it in the ideal position, and then building the operator position around that ideal location of the equipment. From there, adding functionality such as height adjustment, lighting, environmental controls, etc. And then you continue to move outwards and understand kind of the relevant adjacencies, communication, traffic flow, etc. So really, it should start around the operator and go from there. And so you can see in some of these examples where the physical ergonomics very much drive the design of the room. So everything is tailored exactly to the specific operational requirements in terms of physical ergonomics. Another very, very important element is lighting, because it mitigates operator fatigue. It certainly promotes alertness and energy levels, and it improves the overall environment. So when you look at some of the facts on lighting levels, so when you're standing outside on a sunny day, you're experiencing about 10,000 foot candles of light. Full daylight on kind of an overcast, cloudy day is about 1,000 foot candles. Most recommended office environments are about 500. And unfortunately, most comm centers are between 100 and 250 foot candles. And I'll explain kind of what that means. So this is probably what you're used to seeing in most comm centers. Insufficient lighting levels really make it very difficult to create a healthy environment. And it really promotes the decreased levels of alertness, and it becomes extremely challenging in shift work. And the reason I say that is because we all have something called a circadian rhythm. So this human rhythm is a natural evolutionary way that our bodies have kind of adapted to kind of the difference between night and day. In other words, our body naturally kind of when we wake up from a sleep, we have kind of our highest alertness probably somewhere around 10 in the morning. So, our body's ready to go. Between 10 and 3, we kind of have the best coordination, the fastest reaction time, everything else. But then as the evening approaches, and this is through, thousands of years of evolution, as it starts to get dark, our body naturally starts to release something called melatonin, which is what triggers our body to think about going to sleep. And a lot of this is impacted by sunlight because historically, up until 200 years ago, there wasn't abundant sources of lights 24 hours a day. So humans were kind of naturally tending to go to sleep in the evening, whereas when you think about shift work, that's not the case. And sunlight has something called blue light, and it does stimulate the circadian clock. And there's been significant amounts of research done on how it impacts you. Now, with LED lighting, and the new lights, the source of blue light is now available throughout the night. And effectively, what's happening is it's tricking your body into thinking that it's daylight. And this is starting to have some real implications, as research is showing, on the folks working in these environments. So there's Harvard Medical School research that put 10 people on a schedule that gradually shifted the timing of their circadian rhythms, and their blood sugar levels increased, throwing them in kind of a pre-diabetic state. So levels of leptin, all of these things started changing within the human body. So having a circadian response to lighting is extremely important, and that's why lighting is a very important consideration as you're going through the design of your center. And here's a couple of examples. On the left-hand side is from a process control application. So you can see how well illuminated this environment is. And the right-hand side is a comm center in Texas. And you can see how open and illuminated the environment is. So it really helps the dispatchers kind of mitigate some of those risks related to kind of their circadian rhythms and shift work overall. Another critical element about how does your environment react to reverberation and absorption, so the ability to absorb sound and prevent it from bouncing around. When you look at the image on the upper side of the slide, you can see that everything in this room is treated acoustically. So from the wall panels, which are, they have an architectural element to add some color and brightness, but these are all actually acoustical panels which help the absorption of sound. So when this operator is talking, the sound is absorbed that comes in here. And the same is with ceiling tiles and the floor tiles. They're all specifically designed to have a high, what's called NRC rating, which gives it greater absorption. And then on the bottom side here, one of the things that's really emerging in any kind of mission critical environment that has communication systems is the use of directional speakers. So directional speakers are specific because if you're having radio communication, a directional speaker has a cone of only 20 degrees of dispersing sound. And what that means, or in translation, is only the operator can hear the radio communication. So the audio output from this specialized speaker is so narrow that nobody around them can actually hear the radio traffic. And that's extremely beneficial because it reduces the overall noise environment in the comm center, which is what we want to achieve. And you can see, in public safety applications, how this open design can create a better communication environment, but also emphasizing the acoustical treatment to make sure that the overall noise environment is minimized. So in terms of cognitive ergonomics, one of the primary things to look at is alarm management. And so what you want to ensure that's happening in your comm center is that you have the appropriate visual and audio systems to better break down and display alarms. So integrating alarm systems into visual cues really helps the overall situational awareness in the center. So when you look at this picture of, and this is Harris County, you can see that instead of using a single pole light on a position, the entire operator position is illuminated. And what that means is that it's very easy for the supervisors or anybody to quickly look across the room and see who has a potential issue or requires support. So it really does help increase the overall situational awareness, and this can be integrated into phone systems, radio systems, or any other critical system, or they can be driven manually. In terms of organizational ergonomics, it's really about looking at communication and collaborations, traffic flows, and interactions. And what you're seeing down on the bottom page is just some different iterations of thinking about traffic flows and layouts within the room. And this is not so much from an architectural standpoint, it's much more from a communication and workflow standpoint. So being able to explore these early on is extremely important because you can kind of anticipate some of the scenarios that the comm center is going to experience throughout its life cycle. And part of this is also being able to emphasize on visualization. So early on, being able to visualize in the planning stage, which you can see kind of on the left-hand side here, so that you can give all the stakeholders a clear idea of what the space is going to look like, and then being able to kind of use that as a template to execute. That's the whole idea. So, whatever you come up in the planning stage, and once you have that consensus, you want to be able to execute in the kind of actual project delivery. And that's really what we want to try and achieve. One great example on interactions and traffic flows is New York 911. So this center was built post September 11th, and some of the kind of lessons learned on some of the communication issues. But when you look at this room, it's got, as you can see, a significant amount of operators. It's got police. It's got call takers, and then EMS and FDNY on the right-hand side. So this is a consolidated center that looks after all 5 boroughs. And so I'm just going to focus a little bit on the EMS side. So you can see this layout. You kind of have the call takers, their supervisors, and then this is EMS dispatch. So you've got Bronx, Queens, Brooklyn, Manhattan, and Staten Island. And then, so these are the supervisor positions, and then you have the dispatchers. So the normal workflow and communication in this layout is, the dispatcher supervisor has a direct view of the dispatchers. They also have a direct view to the call taker supervisors and so on. So there's kind of a visual line of communication that is important, because once in a major event, such as September 11th, when you lose communication, having verbal cues is critical. So that's part of the reason why the room layout was done like that. But another important element to consider is what happens not just in normal operations, but in upset scenarios. So how does the traffic flow pattern and the communication pattern change? So if you think about a major event that perhaps happens in Brooklyn that has mass casualties, you can see that the layout of this room, instead of everybody being in separate buildings, now that they're together and they're together in the layout of the center, the supervisor can actually pull in resources from different boroughs, not just electronically, but also visually and verbally within the center. So they can essentially take control of multiple resources outside of their own. And that's the whole idea of being able to kind of design the space to anticipate some of these major events. In terms of architecture and design, as you all know, consolidation of facilities is a significant trend. So early on in the architectural stage, thinking about some of the efficiencies and operational alignment is extremely important. So this is an example of Leon County, where you kind of have a traffic management center, emergency call center, and EOC training center all consolidated in a single facility. So obviously there's multiple benefits with this. You have a single physical security envelope. You have a single server room infrastructure, power infrastructure, building infrastructure. So there's natural efficiencies with that. But when you think about the 3 areas that are here, so an EOC, a 911 center, and traffic management center, in a place like Florida, having these operationally together makes sense, because obviously one of the biggest issues in Florida is hurricanes. And any time that an evacuation is activated, it's these 3 that are key. So, the 911 center, obviously the traffic management center, and the EOC is activated. But you can see this building design that, both the 911 center, which is on this upper left-hand side, and the Emergency Operations Center have clear glass to look into the Traffic Management Center, which has a very large display wall that runs along the bottom here. That allows all three functions to have a full view of what's going on the ground, because they're seeing the camera feeds from the evacuation routes, and they kind of have much better situational awareness. So there's a lot of benefits in being able to consolidate a lot of these functions together. So next I'm going to talk a little bit about technology. So one of the things that's really evolving within kind of mission critical facilities is AV technology. And traditionally, AV technology was thought of always as the large screen displays, but in reality, it's evolving to be much more software-based approach. And it really has come a long way in terms of flexibility and how you display content and consolidate content. Also, there's increased demand for video content and data inclusion coming into the center. So whether you want to observe real-time traffic information or camera information, or any other medium of information coming to the control room, you need to have the video systems that will allow you to manage that better. It also allows for much better collaboration within the control room, but also outside of your comm center, within the EOC, with folks on the ground. So all of this content, if planned properly, can be very easy to share and very flexible, which gives you a significant operational advantage. And it allows the dispatcher to be a lot more proactive rather than reactive. Having the right infrastructure of data communication also allows you to better utilize the backup facilities, and it takes them from being purely backup to giving you the ability to design the facility to be a fully redundant operational backup site. And it can be operationally identical to the primary site, and it can have common position configuration. So when you think about the age of COVID, the example of New York 911, they have one of these fully replicated sites. And so when they needed to, they were essentially operationally able to achieve 50%, call it social distancing, immediately by having half of their resources in one site and half of their resources in another site. So it provides significant benefits from that perspective. And this is just an example of how far some of these technologies have evolved. So this is a backup air traffic control tower for Heathrow Airport in London. So the one unique thing you'll see here is it has no windows, and which is odd for an air traffic control tower. But the reality is that the technology and the fiber optic infrastructure are so well evolved that it allows them to be able to track incoming and outgoing flights pretty much digitally without even requiring a window. So that just gives you an idea of how far the technology has evolved. In this video example, I just want to show you a simple way of incorporating technology into your operation. So this is an EOC during a flood event in Calgary. So they're using a smart board where they're giving instructions kind of to the broader team. Now, the folks out in the field, they have handhelds, which essentially see the real-time information that's being put on the smart board. In addition, they can interact, those users with appropriate permissions can interact back and forth visually. And as you can see, this is a significant improvement in the communication process. It also allows them to use real-time video of the situation. So you can see in this case where the water is rising, where they can identify buildings, not just by building number, but also visually, and say, these areas need to be evacuated. So it just helps the overall communication process. So the idea is to have that kind of increased level of collaboration to be able to kind of address some of these situations more effectively. And I want to talk a little bit about the people. So the workforce profile that's now coming out of colleges and universities is changing significantly, as most of us know. In particular, folks are much more accustomed, or younger folks are much more accustomed of being able to track several different pieces of information on a single monitor, versus kind of, let's call it the older generation, which is used to having one monitor for one source of content. And this is starting to have a really big impact on how we design and think about facilities. So when you think about a configuration where you have a significant number of monitors, where this is starting to migrate to is taking this type of content, and you can see that you have multiple monitors and multiple keyboards, and being able to consolidate them into large displays with essentially a dashboard approach, where the critical views that you want to have are on the two large screens, and then a lot of the other monitors are on the side here that you can simply click on to enlarge, or you can create your own configuration and views. So instead of having 8 or 10 monitors, you can have two high resolution screens that then you can um, digitally be able to create your own, if you will, pixel space or view space. And this has some significant benefits to the operation. Also, with the use of hardware-based KVM and PC consolidation, it allows you to move away from multiple keyboards and be able to design a significantly more optimized operator position. And so where this has an impact is when you think about a typical layout. This layout that you're seeing here schematically of a comm center is what we call a task-based layout. So every functional area is kind of broken down here. The challenge with that is in normal operations it can work, but in any upset scenarios or change in scope for the center, it becomes very challenging to physically reconfigure the space. So one of the things to consider um, is looking at how the actual positions are structured from a technology standpoint. So, I mean, a typical position will have multiple PCs feeding the monitors, and then it'll have multiple keyboards. The first step is to think about consolidating those monitors in what we just talked about, the two large screens with having kind of the four different feeds as a dashboard. And then also thinking about having a smart keyboard, which allows you to toggle and move between different inputs, but use a single input device or a single keyboard. Then the other step is to look at taking those PCs that are at a local position and simply putting them into a side room. Now, this is again, it's not changing the boxes, it's just changing their location. If you were to put them in a separate room, there's two immediate benefits. One is heat, the second is noise, and I guess the third one would be maintenance, because you can maintain all the PCs without actually having to come up to the operator position. But the second benefit is these PCs can actually be placed by functional position. So they can be put in shelves, whether it's call taker, fire dispatch, police dispatch, EMS, whatever the configuration is, they can be stored. And in between that, you can place something called a content switch or a management switch. And what that does is essentially it controls which position accesses which source. So it doesn't matter which operator position within the center you walk up to. Once you log in, it's going to essentially access the right rack of computers and give you that functionality. And so what that allows you to do is essentially have login based operator positions. So that gives you a significant amount of flexibility. The other thing that this provides is it allows you to start including different types of inputs into the room. So whether it's CCTV feeds, live media, whether it's information from other agencies, it could be traffic cameras, it could be, you know, any other source of feeds that you can allow into the control room, and you can manage through this content switch. It also allows you to put in a video wall. So whether that's, basic flat screens that you would buy at Best Buy, or you're looking at a more sophisticated video wall, the point is that you can collaborate and share content. So that anybody within the center, so for example, this position could choose to display something on a common video wall because there's an incident happening. They can very easily push that image to the wall so that the entire center can see it. And not just the center, all of that content through this switch can be replicated to an EOC or other agencies. If you're working on a major incident, you can move a lot of this content around. It can be fully replicated to a backup facility, or it can go to field personnel. So looking at this type of infrastructure early on can provide significant benefits to your operation overall. And so ultimately what this type of technology allows you to do is go from kind of a function-based layout to what we call an agnostic layout, where you can essentially put out the positions, but you can actually interchange between them, because if you wanted to, bring in more resources to manage a fire-related incident, they can simply sit in these positions, or they can take over an EMS position and this person can move to the other side. So the whole idea is that operational flexibility to give you that much more efficiency within your center. And this is not, just what we call a pipe dream. I mean, these rooms are happening. One of my favorite ones is a consolidated center in Switzerland. And so they have the same workstation design as you can see in this picture, but they do three very different functions. They do traffic management, police service, and fire service. What they also do is integrated physical security and building management. So everything is run off of this singular consolidated keyboard, and then their screens can access different type of content. And notice none of them have PCs at the operator positions. They're all in the server room with that content management switch. So it allows them to perform all of these different functions. And then you can see along the top here, this is all of their building systems. So the dispatchers can have access control, can have, complete oversight of their physical environment as well. So it's a really good example of how using this consolidated and collaborative technology can really be helpful. And so you can see here kind of, these types of keyboards that are being used are not just keyboards, but they also have a full function screen. So you can control your audio, your radio access, you can control what you're seeing on the screens. So there's significant benefits to it. And of course, we're all living in kind of a new reality, and this kind of global pandemic has really elevated some of the questions surrounding operational integrity and risk in comm centers. There's a lot of new ideas that are happening, and thoughts on operations. We've talked to several kind of directors of comm centers whose life is not easy right now. I mean, they have a lot to deal with and think about. But they're thinking about things like social distancing, interactions and traffic flows, building access, the physical building environment. So are the HVAC systems prepared to have adequate ventilation? Um, Screening, how is it done? And then things like redundant sites are starting to really take on a different level of significance, because they're no longer seen as kind of the dusty backup sites, but a lot of folks are seeing the value of having a fully redundant site that you can run an operation on a long-term basis from. There's impacts on layout and occupancy. There's different thoughts on remote operations. So, there's a lot of things going on, but, to kind of try to summarize them, there's a lot of things that can be done both immediately, but also long-term. So when you think about kind of the basic response, the first thing that the folks are now starting to do is things like plexi dividers. So it just allows that operator position to be able to isolate itself from others. And then, as you look kind of broader, folks are starting to look at building HVAC systems. They're starting to look at things like remote screening. So you can see in the lower right-hand image, instead of having folks come into the comm center, you can actually set up the thermal cameras outside, so you can do your screening without actually having an exposure within the center. So you don't have to look for dedicated space for isolation. So these are the types of things that are kind of easy wins. And then as you become more complex, folks are starting to look at things like remote access, which is very much tied to technology. Layout planning, task separation. So who needs to be in the comm center versus who can be in different facilities, technology management. And then those that are kind of in a position to plan new centers, they're starting to think of risk mitigations based on building design, replicated sites. So, it starts from kind of simple complexity and scope, and it kind of grows depending on where you are in your design process. And when we talk about the cost, I think this is always a very important considerations. But if you think about a comm center that costs $5 million overall, and if you assume that $2.5 million is spent on construction, about $1.5 million is spent on technology, and about $1 million is spent on an interior fit out. Everything we talked about in terms of early planning and in terms of having very specific architectural and technology components to efficiently run the center, this is kind of their cost impact. So, going through a control room design process is insignificant compared to the cost of the entire facility, and doing it early. Looking at video management systems, so the ability to move data around, collaborate, they are certainly not as significant as some of the other costs. Investing into acoustics and lighting is also very negligible compared to the overall scale of the project. And having ongoing maintenance of your center is absolutely critical to kind of ensure kind of the longevity of your operation. But here's the flip side. If you don't take these little green boxes into consideration, what's likely to happen is, for example, one of the issues is employee turnaround. And the reason we show this is every single time you have somebody depart, it can cost anywhere from $50,000 to train a new employee in lost time. You have to have secondary employees training the primary, and it takes a year. So there's a significant cost to every time you have employee turnover. And the more turnover you have, the more of a cost impact it has. So that's an important consideration to have. The other issue is disability claims. So that is an actual cost to be quantified. So anytime you have disability claims because of related to fatigue or ergonomics or other issues and factors that dispatchers experience, this is an ongoing cost that should be considered. And as those rack up, you can kind of see how they start creating a counterbalance to the investment of a center. If at any moment there's civil liability, for any potential errors or lawsuits, those can be significant, and it's very hard to quantify those. But most importantly, some of the examples that we have seen from some of the Denise Amber Lee examples is, the human cost of an error. And that's really what cannot be quantified and should be taken into account. So really creating that ideal environment is really focused about addressing some of these concerns and thinking about them early. In fact, 90% of errors are human originated, and usually they happen during relaxed conditions. And we have often seen that an upset scenario is what truly tests a control room environment. In fact, I would encourage you, if you've not had a chance, to kind of hear Matt's story about the Mandalay Bay shooting, but also Nathan's story about the Denise Amber Lee incident, just to kind of give you an idea of how this can impact the actual control room environment when these incidents happen. And really, it's all about operator-focused design. I mean, that is the key in ensuring maximum safety and situational awareness. Like we said at the beginning, this entire center is designed around the operator, and that's really who we want to make sure is alert and aware and comfortable and frankly happy in the environment, because they do such an important job, or you do such an important job, that they need to have everything perfect, if you will. And there's a tremendous opportunity to leverage technology that's out there and lessons learned to really be able to apply that to creating that ideal environment. And early planning and inclusion of all stakeholders is absolutely key, because then everybody has the chance to contribute to the design of the operation and see it executed and built in the right fashion. And look after your center. I mean, it's your center. It's extremely important, and take care of it. So that is kind of the presentation that I had today. Hopefully provided you some insight and benefits. If you have any questions, or if you would like to chat about lighting or acoustics or operational planning or anything, please feel free to contact us, reach out to us. We'd be happy to have a conversation. And I want to thank you again for taking the time to attend this presentation. And yeah, thank you.